I just want you to be aware that this is a typical examination question that you must expect next week. Right, so the question is on interpretation, obviously. So you are given a quadratic function there and a linear function. So the first question says, write down the coordinates of C. So C is this point here, which is an x. So it's a y-intercept of the quadratic function. So based on the equations that are given, f of x is equal to x squared minus 4, and g of x is given as minus x plus 2. So your coordinates of C, if the question says coordinates, it means you must write both an x value and a y value. So at C, the value of q is negative 4, but x is 0. So the coordinates of C are x is 0, y is negative 4. Okay, you don't need any calculation there. Then the coordinates of D, which is this point here, that's the y-intercept of the straight line, right? So from the equation of the straight line, that positive 2 is your y-intercept, or is the value of y at D, and x is 0 at D. So the answer for D, for coordinate of D, will be x is 0, y is 2. Then the next question says, determine the length of CD, right? CD is a vertical distance. So this will be y max minus y minimum, and that will be, now in this case, now we have to use the value of y at D and the value of y at C. So our y max is going to be 2 minus y minimum is minus 4. So the answer then is going to be 2 plus 4, which gives you 6 units. Okay, this question is, it's also 1 mark. You can do, you can just write the answer without any calculation. But I know that some learners might have an issue finding that vertical distance, so it's better to do a calculation. Okay, so that's straightforward. Any question?
No, sir.
Then 5.4 now, we want to determine the coordinate of B. Now, point B is this point. It's an x-intercept. Okay? It's an x-intercept. Therefore, we have to use, it's 3 marks, so we have to do a calculation. So we have to use the equation of the parabola. So that's f of x equal to x squared minus 4. Since y is 0 at B, we substitute f of x to 0. Alright? And then you can factorize this, or you can use the equation I taught you in class, was an x-intercept. So this will give you x minus 2 times x plus 2 equal to 0. This will give you x equal to 2, or x equal to negative 2. But since the question is saying coordinates, this is very important here. You have to write both an x and a y value. So at B, the x value is negative. So we say, therefore, at B, x is minus 2, y is 0. Then we are done. So that's how you do the question. In order for you to get full marks, you need to make sure that your final answer is written in coordinate form. An x value and a y value. Right? Then 5.5. Now 5.5, you're supposed to determine the coordinate of E, which is the point of intersection. So point E is here. At E, the two graphs are equal. So this is 5.5. So at E, f of x will be equal to g of x. Therefore, x squared minus 4 will be equal to minus x plus 2. Then you solve this. So you get x squared plus x minus 6 equal to 0. Now, it's very important that it formats this step here, equating the two graphs, is very important. Also, the standard form of a quadratic equation is also important. Then we can factorize this, that's x plus 3 times x minus 2 equal to 0. Again, this is also a very important step in terms of the factors, right? Then from there, we say x is going to be equal to negative 3 or x is equal to 2. Now, as you can see, there are two values of x, but we have 2 points of intersection. Now, we have got this point, right? The good thing is we know that at A, x is 2, but we want the coordinates at E. So, this one here, we reject it, x equal to 2, we reject it because x cannot be 2 at point at E. Therefore, x will be equal to minus 3. At what? At E. But this is not the answer. The answer said, the question says, determine the coordinates. So I found the x coordinate. It's a negative 3. I now need to determine the y coordinate. Now, to determine the y coordinate, I have to substitute this value into the straight line or the quadratic, but I prefer to substitute into the linear or the straight line because it's less complicated. So g, it will be g of minus 3 because our straight line is g of x. So that will be equal to minus, open bracket, minus 3 plus 2, and this will give you 3 plus 2, and you get 5. What this means is the coordinates of E. Okay, let me write them here. Therefore, coordinates of E are going to be x is minus 3 and y is a 5. So this will be your final answer. And that makes sense because at E, x here is negative 3 and at E, y is positive 5. Point E is in the second quadrant. Therefore, x has to be negative and the y value has to be positive. Right? So the final answer has to be for that pair of x and y values, that ordered pair. Any question there?
No, sir.
All right, then, now let's do the interpretation question now from the graph. So 5.6 says, for which value of x will f of x be less than g of x? Now, if you want to determine what values of x are such that f of x is less than g of x, what that means is that the graph of f is below the graph of g. So, your critical points are the following. The x-intercepts are critical points. The intersection points are also critical points. Sometimes in your turning point is also a critical point. Well, we could also include the y-intercept. That those are critical points, right? So if f of x is less than g of x, what that means is the quadratic graph is below the straight line. So the quadratic is below the straight line. Okay, so we just have to look at where that is true. Okay, that is only true between this point, that is point E, okay, to the left of point E, the quadratic is above the straight line, so we don't want that interval, right? So from this point up to point A, the straight line is above the quadratic. Therefore, the y values of the straight line are greater than the y values of the quadratic. Or you can say the y values of the quadratic are less than the y values of the straight line. To the right of point A, the quadratic is above the straight line, so we don't want that either, which means we need the value of x there, which is -3, we need the value of x here, which is +2. So our answer for 5.6.1 need to be minus x lies between -3 and +2. So between -3 and +2, the quadratic graph is below the straight line. Right? Any question there?
No, sir.
Right, then 5.6.2, now we want the product of the two graphs to be positive. Right? The product of the two graphs has to be positive. So the question will be for what values of x. Now, honestly speaking, I think you can all agree with me that between -2 and +2, the straight line or the straight line is positive. Right? It's positive or 0, but the quadratic is negative, which means between -2 and 2, we won't get a product which is positive. We won't. Therefore, the only intervals are going to be to the left of point B. The products are going to be positive, and also to the right. Now, if you look at the right now, the straight line is going to become negative, but whilst the quadratic is positive. So even if we look at the turning point, like from this point here and that point, right? The straight line is positive in terms of the y values. Here, the quadratic is negative. So we can also take that point. So the only answer that would be appropriate is actually to the left. It will be to the left of point B. So our answer for that is going to be x must be less than or equal to -2. Okay? So all the values to the left of B will make the product of the quadratic and the linear to be positive. And I'm sure you can see that in the second quadrant, both graphs are positive. Okay? In the second quadrant, both graphs are positive. Right? Let's also look at the first quadrant. Okay? Let's look at the first quadrant because in the first quadrant, both graphs are also positive. Right? They are only positive, or rather I would say the straight line is positive from x equal to 0 up to x equal to 2, whilst the quadratic is negative, so we can take that interval. Furthermore, to the right of 2, the quadratic is positive, whilst the linear is negative. Therefore, for this question, our only solution, okay, our only solution is going to be x is greater than or equal to -2. Right, any question there?
Well, yeah, sir, can you please explain why it wouldn't apply for, the space between the coordinates from 0 to A? Why wouldn't that be a suitable answer?
Okay, well, if you look at from 0, from this point here up to that point, our straight line is positive. Okay, it has got y values that are positive, even though it is decreasing. In the same interval, the y values for the quadratic are in the fourth quadrant, therefore they are negative. Hence, if we multiply the y values of the two graphs between 0 and 2, that is between x equal to 0 and x equal to 2, if you multiply the y values, you always get a negative answer. Because the straight line is positive, whilst the quadratic is negative. Right? It also it also applies for from negative 2 to 0. Okay, the straight line is positive, but the quadratic is negative. All right.
Yes, sir.
So whenever you get a question like this one here, be very careful to rush to get an answer. The first one, 5.6.1, is a little bit easier and it's a bit straightforward. But the second one is slightly more complex. So you have to be very, very careful when you are answering a question like that. Any question?
Sir.
Yes.
For the way you said x is less than or equal to negative 2. Wait, over there, negative 2. I mean, like, yeah, between that, the graph of g of x is above the x-axis and the f of x graph is below. If you multiply that, won't you get a negative?
No. You see, we are in the second quadrant. If you look at in terms of the quadrants, right? In the second quadrant, whereby the values of x are from -2, or I would say they are from -infinity up to -2, right? So we are talking about starting from here, from -infinity up to this point here. Even though the straight line might be below or it might be above, whichever the case, that's not important. We are concerned with the products of the y values of the straight line and the y values of the quadratic, the product. Don't confuse 5.6.1 and 5.6.2. 5.6.2 is talking about what values of x are such that the products of the y values will always be positive. So in that case now, whichever graph is above or below, as long as their y values are positive, it means the product will always be positive.
Oh, I understand now, sir. I see you now.
You understand what I'm saying? So we are in the second quadrant. Both y values for the two graphs are positive. That's why we are going to end up having that interval. Now, this 5.6.2, you can also write it as x is an element. We are starting from -infinity up to +2. But you have to include the -2. So you can also write it like this, or you can also write it as -infinity is less than x is less than or equal to -2. Now, this equal sign here is very important, and that square bracket is important. That equal sign there is important, and it comes from here. That's where it comes. So when you are answering the question there, you must also check whether the original question includes the end point or not. Generally, for -infinity and +infinity, we don't include them because remember, -infinity and +infinity are not specific values. Therefore, we use the circular brackets or the inequality sign without an equal sign. Right, then the last one. Now we want to calculate the length of BK. So this length here, right? Or rather, we want to calculate AK, rather, which is from here to there. Now you can see that triangle ABK, it's a right angle triangle because that angle is 90, right? So all we have to do is determine the distance of AB, determine the distance of BK. Alright, now I'm going to show you something which I haven't shown you before. So first thing, let's find the length of AB. It's a horizontal distance. So that's x max minus x minimum. Our x max is a 2, x minimum is minus 2. Therefore, we get 4 units. That's the length of AB. Then the length of BK, right? We know that x is equal to 2 at b. It's also 2 at k. So the value of x at b is the same as the value of x at k because bk is perpendicular to the x-axis. Therefore, bk is parallel to the y-axis. Okay? So if I want to find the length of bk, all I have to do is say y max minus y minimum. If you want, you can calculate them by substituting x equal to negative 2 into the straight line and into the quadratic. Then you get the y values. But the y value at b, it's a 0. So just have to find the y value at k. Okay? So at k, okay, the y value we substitute the straight line. So we say g minus 2 will be equal to minus 2, right? Plus 2. And this will give us a 4. So what that means is that bk is going to be 4 minus 0, which is again 4 units. Okay? Therefore, to get the length of AK, we just use our knowledge of geometry. So in triangle ABK, we'll say AK squared will be equal to AB squared plus BK squared. This is Pythagorean. Right? So this becomes AK will be equal to the square root of 4 squared plus 4 squared. Alright? Now we'll get square root of 32. Right? And my final answer, I can write that square root of 32 as 4 square root of 2 units. Okay, I'm not going to convert it to a decimal because that's not necessary. But maybe if you want, you can do it. I'm just going to leave my answer in said form. So AK will be equal to 4 square root of 2 units. Okay? Which if you want, you can convert to a decimal, but you can leave it like that. All right. Any question there?
No, sir.
All right. So if you don't have any question, then we will stop here for today.